Hi guys, my name is Faith Badro. Today we're looking at the topic periodic table trends. Sit back and relax. We'll be right back. Welcome back. Today we're going to be looking at periodic table. I'm sure you have all heard about periodic table. In fact, you have seen the diagram, you have seen the picture of the periodic table that contains the elements. But today we want to dissect this periodic table. We want to show you the trends, what happens on that periodic table, so that when you see that periodic table, you can know and understand what you are seeing, because there is more to what you are seeing on that your periodic table. Now, the periodic table isn't just a chart of elements. Yes, it's not just a chart of elements. There are some things that are there that you must know. It actually shows patterns in how elements behave. Now, this periodic table will show you that, oh, these particular elements that have this color, they behave this certain way. These other ones, they behave this certain way. These patterns are called the periodic trends. The periodic trends. And they help us to predict how elements will react. They help to predict how elements will react. Because from the periodic table, to show you that, oh, these ones are the metals, and this is how metals are going to react. These ones are the non-metals. These ones are the metalloids. In different situations. The main trend you should know are atomic radius, ionization energy, electronegativity, and electron affinity. So we have four main properties that we can deduce from this our periodic table. The first one is the atomic radius. The second one is the ionization energy. The third one is the electronegativity, and the fourth one is the electron affinity. Now, these four properties, they come very, very well in our examinations. They come repetitively. Now, this is a diagram or a picture of our periodic table. Now, you can see these numbers that are here. These numbers that are horizontal is telling us about the period. When we go from left to right on the periodic table, we're talking about the period. But when you hear that we are going from up to down, going from top to bottom, we're talking about group. So now this periodic table is grouped into periods and group. Like this is the periods, like this is the group. Now we have group 1, we have group 2. Now if you look at this, from this group 3 to this group 12, you can see that they are different. They now start naming this one 13, 14, 15, 16, 17, 18. But normally, for your level, there are 8 groups. Group 1, group 2, group 3, group 4, group 5, group 6, group 7, and group 8. These are the most important groups in chemistry. Now, this group 1, and notice that when you are looking at your periodic table, you have to have a key. There is always a key in that your diagram. Now, in this key, they are told us that if we see red, red means for the alkali metals. Amber is for the alkaline earth metals. Yellow is for the transition metals. Blue is for the post-transition metals. Light green is for the metalloids. This one is for the non-metals, this one is for the halogens, this purple is for the noble gases, and so on and so forth. Now, the alkaline metals, these are the group 1 elements, and they are red. So that's from lithium to this one, and like that, like that. So that's how you can know your periodic table. And these numbers that are here, they are known as the atomic number. They are the atomic number. Now, if you notice, it is arranged according to their numbers. Now, it's not coincidental. They do not just assign any number to this element. That number is their atomic number. That is how many electrons or protons that particular element has. Now let's look at the first property, atomic radius, or sometimes you can say size of an atom. Now we should all know that the word radius, what does the word radius mean? Now if you look at your circle, they will tell you that any point from the middle of that your circle to the circumference is your radius. That is your radius. Now every element, the atom of every element, they have different radius, and it is a property of these elements. So now I want to see that going from the period, across the period and down the group, you want to know that this atomic radius, what happens to these elements? Atomic radius refers to how big an atom is. It's telling us how big the atom is. Basically, the distance from the nucleus to the outermost electron, like what I said now. Now, this is the electrons, this is inside, this dense part in the atom is the nucleus. Now, the difference between this and this, that is your radius. Now, what happens down the group? Down the group, which is top to bottom, atomic size increases. Why? This happens because new electron shells are being added, making the atom bigger. Now let's look at it. Now if you look at this periodic table, let's just take this group 1. We are talking about atomic radius down the group now. Now let's take lithium number 3 and sodium number 11. Now that's lithium number 3. Now if you want to draw it, there are 2 electrons on the first shell. The second shell, we have 1 electron. Now sodium, which is 11, if you want to draw the shell, 2 here, 8 here, and 1 here. Now let us count how many shells. If you look at this lithium now, the shell is just 2. There are just 2 shells here. But if you count this sodium, you can see 1, 2, 3. 3 shells. Now, are you telling me that the distance from these 2 shells, from the middle to this end of this electron, and the one that has 3 shells, now the one that will carry the more distance, the one that is going to be higher, the radius that is going to be higher, is obviously sodium because it has 3 shells, while lithium has 2 shells. Now, this is the reason why we say down the group, the atomic radius increases. This is an evidence to why it increases. This happens because new electron shells are added, making them bigger, as we have just seen now. Now let's look at what happens across the period. So for going from left to right across the period, what happens to this atomic radius? Now the atomic size decreases across the period. We have seen that it increases down the group. Now across the period, it said it decreases. Why? Even though electrons are added, the nucleus becomes more positively charged, pulling the electrons closer. In simple terms, atoms get bigger as you go down, but smaller as you move across. Now let us see why that happens. Let's take from the period, let's take 2 elements again across the period. Now let's take 3, Li and Be. They are both in period 2. Now Li, that's lithium is number 3, beryllium is number 4. Now if we take that, we are going to have lithium, beryllium. Lithium is number 3, beryllium is number 4. Now, if you notice, something is happening when you are going across the period. Shells are not being added. Shells are not being added. What is being added are electrons. Now, these electrons, they are, reacting with the nucleus. They are reacting with the nucleus. There is something that's called attraction is happening. We call that the screening effect. The screening effect. The screening effect happens. This is repulsion between the nucleus and the electrons. And this allows these electrons, they will now try to attract to that nucleus. It's now going to decrease the size of the atom as a whole. So this is why when we are going down the group, the size is going to increase. Why? Because we are adding shells. But going across the period is going to get smaller. Why? Because of the screening effect, because of repulsion. And we have seen that shells are not being added when we go across the period. So this is what happens in the periodic table on atomic radius. Let's move to the next property. Ionization energy. Now, what does this mean? It is the energy that is needed to remove an electron from an atom. It is the energy that is needed to remove an electron for an atom. Now, let us know that what this energy, does it down the group across the period, does it increase, does it reduce? Let's look at that. Now, down the group, the energy decreases. It decreases down the group. And why? This is because outer electrons are further from the nucleus, so they are easier to remove. Let's read that again. Down a group, for ionization energy, it decreases. Why? Because the outer electrons are further from the nucleus, so they are easier to remove. Now let us look at that. Let's go back to our periodic table and look at down the group. What happens down the group? Now down the group, we are going from 3, 11, 19. We are going from 4, 12, 20 to 38. We are going from 5, 13, 31, 6, 14, 32. Now let us still compare our lithium and sodium. Let's still compare that. Now if you see lithium and sodium, okay, lithium and sodium, we said that lithium is number 3, while sodium is number 11. Now lithium is 2, 2, 1, that's for lithium, while for sodium, okay, it is 2, 8, 1. Now the reason why it is decreasing, they said it is decreasing because the outer electrons, they are getting further from the nucleus. So as we go to 281, this last electron, the final electron, the outermost electron is getting further. Why? Because more shells are being added. So it's getting further. What is after sodium? After sodium, we have potassium, which is number 19. Let's do the one for potassium. Potassium looks like something like this. 2, 8, 8, 1. Now you can see that they are going down the group. This outermost electron is getting further away from the nucleus. Now another thing that you can use to know it is that the reason why it is decreasing is because when you go down the group, if you look at this, you will notice that this one is very easy. This one is very easy for them to lose this electron. So as they are going down, it's getting easier. Why? That repulsion that is making that electron to be intact in the middle is getting weaker as the shells are increasing. That is why down the group, this energy is decreasing. Now let's look at across the period. Across the period, electrons are held more tightly by stronger nuclear charge. Why? Because there is no significant adding of shells that is making them further away from the nucleus. Now let us look. Now we say that it increases across the period. Now why does it increase across the period? Let us look at why it increases across the period. Okay, let's take lithium, beryllium, and boron. We'll take lithium. Let's take lithium, beryllium, boron, and fluorine. So lithium is 2, 1, beryllium is 2, 2, boron is 2, 3, fluorine is 2, 7. Now this is lithium, this is beryllium, this is boron, and this is fluorine. Now, if you notice, going across the period, this outermost number is increasing. Yes, it's increasing. So I want to explain why this, they are saying that this energy increases across the period. Across the period, this outermost number is increasing. Now, think of it like this. For lithium, no, we have one outermost shell. Now, this one outermost electron. Now, the energy required for this one, the energy that we require to remove this one, it will be very easy. Why will it be very easy? Because it's just one. Now look at this one. So we need little energy to remove for Li. Let's look at beryllium. We have two outermost electrons. Now the energy that will be needed to remove these two will be more than this one, but not so much at the end of the day. Let's look at boron. We have three here. The energy that we use to remove these three outermost shell will be, significantly more than these two, but not still very, very great. Now let's now compare the energy that will now be used to remove this 7 from fluorine. It will be very, very hard, because the energy that we require to remove 7, and if you compare 7 and 1 will be easy, it's easy now, but this 7 need to be hard. This is why we say that the energy is increasing across the period and decreases down the group. Now think of it like this. The closer an electron is to the nucleus, the harder it is to pull away. So that is it. Okay, so now we have electronegativity. Now this is our third property, is electronegativity. We have seen atomic closures, we have seen ionization energy. Now we're looking at electronegativity. Now when we hear electronegativity, what are we talking about? It is the ability of an atom to attract electrons when it is bonded to another atom. It is the ability of an atom to attract electrons. Why? Now if you notice, let's look at an element that is electronegative. Now an element that is electronegative is, for example, we can say fluorine. Fluorine is very electronegative. Now if you notice, fluorine is 2,7. Fluorine is 2,7. Now this fluorine, if you notice this fluorine now, it needs 1 electron. So it will attract electron. Why will it attract electron? Because they are electron acceptors. They attract electrons. That's why we say that it's the ability of an atom to attract electrons when it is bonded to another atom. Now what happens to this electronegativity down the group and across the period? Now down the group, it decreases, while across the period it increases. Now why? Let's go back to our periodic table and check why that happens. Now if you look at across the period, let us say we are going from lithium, that's from lithium to beryllium to boron to carbon to nitrogen to oxygen to fluorine to neon. Now let us say that's what we are following now. Now if you notice, lithium is a metal, beryllium is a non-metal, boron is metalloid, carbon is a non-metal, non-metals. And look at, we said non-metals are generally electron acceptors. That means normally non-metals will attract electron. That means normally non-metals are electronegative. So they have that electronegativity in them. But if you are going down, let us look at this from here. If you are going down the period now, you will look at something. Let's look at this period 14 now. If you are going down, oxygen, carbon. Now this carbon is a very good example of a non-metal. Silicon is a metalloid. That means it's neither a metal and neither a non-metal. This germanium is a metal. Tin is a metal. Lead is a metal. This one too is a metal. Now can you notice a trend here? Now the trend that is following is that as you are going from up to down, you are going from non-metals to metals. If you look at this place too, hydrogen to lithium to sodium, hydrogen is a non-metal. Going from here to here, barium is a non-metal. Going to magnesium, magnesium is a metal. But if you are going across the period, you are starting from metals, we will now end at non-metals like we saw. Let's look at it. Sodium, magnesium, aluminium, then we now get to silicon, which is the metalloid. We now enter phosphorus, which is a non-metal. Sulfur, chlorine, argon, these ones are non-metals. So that means that when you go across the period, electronegativity is increasing. But when you go down the period, because we are going to the metals, when you go down the group, electronegativity is decreasing. Now, fluorine is the most electronegative element, as we have seen. Now, elements on the top right of the table are the greediest for electron. That's the top right. Those are your halogens. Now, electron affinity, that's the fourth property, electron affinity. Now, what is electron affinity? It is the energy change when an atom gains an electron. It is the energy change when an atom gains an electron. Now, across the period, generally, it generally becomes more negative. Okay, now let us look at this. Electron affinity. Now, the word affinity, let's look at the word affinity. This word affinity, it means love. Love. Love for electrons. So I'm saying that love for electrons. Which one will have the love for electrons? That we're talking about. So it is the energy change when an atom, we're talking about when an atom gains an electron. Now let's look at an example. Let's look at down the group. If you look at lithium and you look at sodium, now we know that there are three, that is 2, 1 and 2, 1 and 2, 8, 1. Now this, when you are going down the group, electron affinity will always increase, will decrease. Now it will decrease going down the group. Now why is this? Because electron affinity is the ability to gain electron. Now the ability that this lithium, it has to gain electron, it has to gain. It does not really have affinity. These ones, they don't have affinity. Why? Because they don't. In fact, instead of gaining, they are going to give out their electron because they are metals. They will likely give it out. But when you are looking at across the period, when you look at across the period, when you say, for example, okay, let's look at these ones that we looked at that time. We look at this, let's look at this like we looked at the other time. Then, but for this one, we are looking at it based on electron affinity. Electron affinity, that's the ability to gain electron. Now, this Li, it has only one. If it wanted to gain electron, it will have the affinity to gain much electron. Why? Because it only has one. It has just one. So it can still gain 7 more. So it has, we can say it's one will have great affinity, great love. Now if you look at beryllium, it has 2. It needs 6 more. So we can say it also has the affinity, but not so much. If you look at boron 2, 3, also it can still gain how many? It can still gain like 5. So we can say that it has the affinity, but not. But when you now look at this 2, 7, it needs just 1. Just 1. So you can see that it does not really have great affinity for this element. It does not really need it. Why? Just only 1. So because of that, we can see that as we are going from this is across the period. As we are going across the period, we are seeing that this electron affinity is decreasing. Why? Because this Li, needs 7, this one needs 6, this one needs 5, this one needs just 1. So it is decreasing. That is why we can say that electron affinity will decrease across the period and it will increase down the group. Now, a quick summary table for the trends. Atomic radius down the group, it will increase. Across the period, it will decrease. Electron energy down the group will decrease. Across the period will increase. Electronegativity down the group will decrease, while across the period will increase. Electron affinity down the group, it will increase, and across the period it will decrease. So these are the trends, or you can say less negative and you can say money, but the one that we use is increase or decrease. Now this is a very quick summary of the trends. So we have seen 4 major trends. We have seen atomic radius, ionization energy, electronegativity, and electron affinity. Now examples. If we compare sodium and potassium, potassium is below sodium in the same group. So it has a larger atomic radius and lower energy. This means potassium loses electrons more easily than sodium. Like we have seen this, but now when we have done this, we compared sodium and we compared potassium. We saw that potassium had more shells than sodium. We have already done this. To compare carbon and oxygen. Oxygen is further across the period, so it has a smaller atomic radius and higher electronegativity. That's why oxygen attracts electrons more strongly than carbon. So we have seen that across the period, the atomic radius is decreasing, and because oxygen is further than carbon, because sometimes your question can come like that. They can say compare carbon and oxygen, but will not tell you that which of these ones have higher radius, which one is more electronegative. And don't forget that going across the period, we can say that the radius is getting smaller, and we can say electronegativity is increasing. That is why, and since oxygen is further than carbon, we can say that oxygen is smaller than carbon, and it is also more electronegative than carbon. So, and this electronegative atoms, they have the ability to attract electrons more strongly. That's why oxygen attracts electrons more strongly than carbon. Now, for your assignment, number 1, explain why atomic radius decreases across a period but increases down a group. We are going to explain why does atomic radius decrease across the period and increase down the group. Now, these assignments, make sure you drop them in the comments section. Number 2, between magnesium and chlorine. So you'll be comparing magnesium on the periodic table. You'll be comparing chlorine also. You are going to tell me which one has a higher ionization energy, and you're going to tell me why. Don't forget that we said the ionization energy of an atom is the ability of an atom to lose electron. So you're going to tell me between magnesium and chlorine, which one will have the ability to lose the electron, and why is that? So we have come to the end of our class. I hope you enjoyed the class. Make sure you do your assignments. Make sure you drop your assignments in the comments section, and make sure if you have any questions, don't just ask the question. Drop it in the comments section.
Hi, I'm sure you enjoyed the video you just watched. To see more content as that, prepare you for your upcoming exam, make sure to smash the subscribe button and turn on notification. Also, remember that you can use the comment section to send us your questions or your inquiries, and we are happy to take them. I'll see you in the next video. Bye.